Ever pondered over what the codomain of a function is? Let's dive into the world of functions and their codomains. Imagine a function as a machine that takes in inputs and spits out outputs. Now, the codomain of that function is like the universe of all possible outputs that the machine could produce. It's the set that contains every possible result the function could give, even if there are some values that it never actually reaches. Consider the function f of ax equals ax squared. Here the codomain is the set of all real numbers, often written using set notation as curly braces enclosing y belongs to the set of real numbers. But how do we identify the codomain? Well, it's usually provided when a function is first defined. Nevertheless, in certain instances, it's possible to deduce the codomain from the function's formula or its graph. Let's take a tour of some functions and their codomains. For a linear function, the codomain is the set of all real numbers. It's the same for a quadratic function and a rational function. However, for a radical function, the codomain is all real numbers greater than or equal to 0. An exponential function has a codomain of all positive real numbers, while for a logarithmic function, the codomain is all real numbers greater than 0. Now, understanding the codomain of a function is crucial. It's like having a map that shows all the possible destinations the function can take us to. Not only does it help us comprehend the potential output values, but also aids in graphing functions, as the codomain determines the range of y values that can be plotted. But don't confuse the codomain with the range of a function. The range, you see, is the subset of the codomain that the function actually reaches. For instance, the range of the function f of x equals x squared is all non-negative real numbers, even though the codomain is all real numbers. In summary, the codomain of a function is a vital concept that offers a better understanding of functions and their properties. It plays a pivotal role in various mathematical fields, including calculus, analysis, and topology. So next time you come across a function, remember to consider its codomain, the universe of its possible outputs.